Hey everybody, this is the notes for 6.6. This is sums and differences of cubes. This is another special case. Just like difference of squares and perfect squares, it really helps you if you recognize these, because if you don't, they're pretty darn hard to factor. Just like when we saw differences of squares, they really just come in this format and you have to know how to do this. What you need to be able to know in advance to be able to do this, though, is what the perfect cubes are. So, like, 1 is the cube of 1 squared, 8 is the cube of 1 cubed, 8 is 2 cubed, 27 is 3 cubed, right? And so on. If you don't have these at the tip of your fingers, it's time to arrange it to be so. Here is the format for these. So when I have a cube and a cube added together, what I'm going to do is I'm going to write the base, a single. So like if a cubed was an 8, I would write a 2 because 8 is the cube of 2 plus b times a squared minus ab plus b squared. Here's what I want you to see. There is always 2 pluses and a minus in this format, okay? It's just that depending on whether or not it's a sum or a difference of cubes is where the minus goes. So in a sum, the minus comes second. In a difference, the minus comes first in the initial binomial. And then that's really what you need to be able to remember to do this. So this is a sum of cubes. W cubed is a cube, 64 is the cube of 4. So really I'm going to think about W and 4. And then I'm going to put it into the format that was on the previous page. So it's A plus B, so W plus 4 times A squared, which is W squared, plus A times B, minus A times B, which is 4W, plus B squared, 4 squared is 16. And that is done right as it is. It's finished. That's the factored form. Look at the second one. The base of P cubed is P. 125 is the cube of 5. So 5 times 5 times 5 is 125. So then we put it in the format. P, A plus B is P plus 5. Then B, A squared, which is P squared, minus A times B, which is 5P, plus B squared, which is 25. That's it. This is done. This is just a matter of remembering the steps. Now, sometimes they look a little uglier. So what? Doesn't change anything. As long as everything is a cube. 27 is the cube of 3. P cubed is the cube of P. 1000 is the cube of 10. And Q cubed is the cube of Q. Whew, that's going to be horrible on the transcript. Okay. Same format. This is a difference, and what I need to remember when I factor a difference of cubes is that the subtraction sign goes in the binomial rather than in the second part. So then it really is the A term, which is 3P, the B term, which is 10Q, and then the A term squared, which is 3 squared P squared, which is 9P squared, plus A times B, 3 times 10 is 30PQ, plus B squared, which is going to be 100Q squared. That is it. It is finished. Same thing in the next one. So think about what the single of the cube is, the base. So it's going to be 2y and 3z. And then we just put things into place. So this is a difference. The minus sign is going to go in the binomial, and then I'm going to have pluses. So it's 2y minus 3z, and then 2y squared, which is 4y squared. 2y times 3z is 6yz. And then 3z squared is 9z squared. Done. All right, they're not always going to be that simple, just bear in mind. So now we have 3 different kinds of things we're looking at here. We have difference of squares, difference of cubes, sums of cubes. These are the special cases that we really have to pay attention to. This should be a minus sign right here. I have it wrong somehow. Okay, so now we're gonna test out if we can tell them apart, okay? So factor the first one completely. Look at it. What do you see? I see 27, which is definitely not a perfect square. So it's in a y cubed. So I'm going to think, is that a perfect cube? Well, yeah. 27 is the cube of 3. Y cubed is the cube of y. And 1 is the cube of 1. Okay, so it's a plus sign. The plus goes in the binomial. So 3y plus 1 times a doubled, which would be 9y squared. 1 times 3y, the minus goes there. So it's 3y plus 1 squared is just 1. Done. Look at the second one. I see 1 over 25. 25 is not a cube, it's a square. I see m squared, that's a square, minus the difference, 1/4. Those are all squares. You don't have to do anything complicated here because this is just 1/5 times 1/5, right? This is just half times half. 1/4 is. So difference of squares means I take the first term, 1/5 m, minus the second, half, times same stuff, oops, with a plus sign, 1/5 m plus half. And then look at the bottom one. So name what it is first. Well, z to the 6th can be even, so it could be a perfect square, but the 8 tells me this is a cube. Whenever you see an 8, you should be thinking in cubes. So when I'm thinking in perfect cubes, if I have z to the 6th, that's z to the 6th divided by 3. We're dividing by 3 or dividing by cube. So the base is going to be z squared. And for the second one, it's going to be 2w. So this is a difference. It means the minus goes first. So it's going to be z squared, pardon me, minus 2w. And then z to the 4th, so double z squared, plus 2wz squared, plus 4w squared. Okay? You try these three, name what they are, and then write out the answers. Okay? First one should be a difference of cubes. So it should end up being 10x plus 1 times 100x squared minus 10x plus 1. The second one is a difference of squares. So it would be 5p minus 1/3, 5p plus 1/3. And the last one is a difference of cubes also. So it's going to be 3a squared minus b because it's a difference. The last one's a difference of cubes. I think that's what I said. And then 9a to the 4th plus 9a to the 4th b. Oh, no, not 9, just 3. Pardon me, I'm not ahead of myself. Plus b squared. Okay. All right, these ones look a little funky. So something weird is going on here. They don't look like a difference of cubes or a difference of squares. What the heck? Well, so what I'm going to do is I'm going to look for a common term, because when something looks funky, there's probably something extra in there. And for 3 and 48, the common term is 3. So I'm going to pull out a 3. I'm going to get 4y minus 16. Well, now what do you have? I have a difference of squares. Because as long as it's an even exponent, it's a perfect square. So it's going to be 3y squared minus 4, y squared plus 4. And remember, when we have that double there, we have an extra trick, right? Because that y squared minus 4 is also a difference of squares. So I have to factor again. I'm going to factor that to y minus 2, y plus 2, and then y squared plus 4 just is. That's a sum of squares, and I can't do anything with it. It's prime. Okay, try the next one. I'm going to take out the common term because it looks funky. It's 2, so I get x to the 4th minus 1. Okay, then that is still a difference of squares, right? X squared minus 1, x squared plus 1. And then once again, we have that middle term that still needs to be factored further. So 2x minus 1, x plus 1, and then x squared plus 1. All right. Uh-oh. Now what's happening? Well, remember that when you see 4 factors, your brain should always go, oh, factor by grouping. So let's do that. So I'm going to take 4x squared out of the first one, and I'm left with x plus 1. Out of the second one, I want to take minus 25. That leaves me with x plus 1. So I'm going to pull the common factor to the front, x plus 1. And I'm left with 4x squared minus 25. Well, at this point, I know I have 4x squared and a 25. That's a difference of squares. So I'm going to take x plus 1. And then I'm going to factor this out. That's 2x minus 5, 2x plus 5. All right, we didn't die. Try the next one. You do the same thing. When you are finished, you should get x plus 2, x minus 2, x plus 6. Okay, you're stuck. Come to the discussion. All right, we have this binomial. This guy's kind of special. We're going to factor it as a difference of cubes and as a difference of squares. Either way works, interestingly, because 6 is one of those strange numbers that's divisible by 2 and also by 3. So we're going to do difference of squares first. So if it's a difference of squares, I'm dividing 6 by 3 and I'm by 2, and I'm going to get 3 as my exponent. So I'm going to have x cubed minus y cubed, x cubed plus y cubed. Okay. And then this is also like difference of cubes. We could keep going, right? That's a difference of squares. So this guy is still a difference of, all right. So then let's try this as a difference of, difference of cubes. So what I would do is divide by 3 instead of 2. So I'm going to do x squared minus y squared times x to the 4th plus x squared y squared times, plus y to the 4th. Okay, when I FOIL them back out, it's going to be the same. It's all going to work. All right, what do I do with this one? Well, I can treat it as a difference of cubes or a difference of squares. Either way would work because of this 6. And 64 is one of those strange numbers that is both a perfect square and a perfect cube. So you try it, see where you get. As a difference of squares, it's z cubed minus 8, z cubed plus 8. And I can factor that further as a difference of cubes. I just don't want to like overcomplicate it for you guys at this point. And as a difference of cubes, it would be z to the squared minus 4, z 4 plus 4z squared plus 16. And you would know at this point, this is also a difference of squares. You can keep on going, okay? So you're going to keep breaking things down. I just don't want to like belabor the point here. We can talk about it in the discussion if you want to look at it further. This is the end of this section, and we have one more to go. See you there.